Good morning, my dear students. Today I will continue this chapter, that is matter and its composition. In my last class, I discussed about the liquid state, and today I shall discuss on gaseous state. Okay. So you can easily prepare gas. If you take any solid, if you apply heat, then it will turn into liquid, and then again if you apply heat at higher temperature, okay, then that liquid will turn into gaseous state. Here we have taken ice. All of you know ice exists at 0 degree centigrade, and if you apply higher temperature, then it will become water. That means liquid state. And if you boil water at 100 degree centigrade, higher temperature, then what will happen? There will be formation of water vapor, that is gaseous state. So in this way we can easily prepare gas, okay, from any state. Now, one chemist, Jean Baptiste van Helmont, first identified that carbon dioxide gas. It was the first known gas other than air. There are different types of gas like hydrogen gas, oxygen gas, nitrogen gas, fluorine, chlorine gas, helium, neon, argon, krypton, xenon. They are called noble gas. These all are called elemental gas. Only one kind of element is present. Hydrogen, oxygen, nitrogen, fluorine, they are called diatomic gas. So because they contains in their molecule only 2 atoms, okay. But helium, neon, argon, okay, are called monoatomic gases. They are not forming bond with other atoms, okay. So they remains as atomic state. They are not forming any diatomic gas, okay. And so these helium, neon, argon are monoatomic gases. And we are surrounded by gas, that is nothing but air. And air is a mixture of gas. Air contains 21% oxygen. That is why we are alive, okay. Without oxygen we cannot survive our lives. And 78% is nitrogen. That is one inert type of gas. And 0.04% carbon dioxide. And 0.90% argon. And traces of other noble gases with water vapors. Most of the gases are colorless. So it is very difficult to observe these gases. Okay. Some gases are colored, like fluorine gas, which is yellow in color. Chlorine gas, this is greenish yellow in color. Iodine gas, okay, it is violet in color. Bromine gas is reddish brown in color. And nitrogen dioxide gas, this is also reddish color, okay. Now scientists who worked on different properties of these gases are Robert Boyle, and according to his name there is one law that is called Boyle's law. Jacques Charles law is there. Amadeo Avogadro is there. Van der Waal is there. Gay-Lussac is there. John Dalton is there, okay. So these are the name of the famous scientists who work on the different properties of gases, okay. Next we will discuss that the definition of gas. So you can tell the gas is a state of matter which has neither definite shape nor a definite volume. So in the gaseous state, the matter is characterized by lack of definite volume or shape. In case of gases, the intermolecular force of attraction between two molecules is negligible. and the intermolecular space are very large. The gas particles can move freely from one place to another place, and they occupy the entire volume of the containers, whatever volume or size it may be. So gases have no fixed shape and fixed volume. Gases can flow in all directions, and they are always in random motion. They are also following the Brownian motion. Okay. If we apply pressure on gas, they are easily compressible to a certain volume. So here I am showing that this syringe, okay, here what is there outside? Air is there, okay. So now here one hole is there. We have to block this hole by putting this finger. Then inside there is air. Now we are just adjusting this piston inside this, or putting this piston inside this, and then we are applying pressure. What you are observing? That we can press, okay, the air and the volume decreases. So that means gases are compressible, but to a certain extent. Now we cannot give, we are applying more pressure, but we cannot reduce the volume of this gas too much, okay. So that is why gases are compressible, okay, at high pressure to a certain extent, okay. And when we are putting this finger here, we are feeling that inside this pressure is there. Actually, whenever a gas is present in a container, the particles are always in random motion, and they are colliding with each other, and they are colliding also with the wall of the container, and this collision, okay, is responsible for the pressure of the gas, okay. Now all gases are transparent in nature, and these gases are not lustrous. Some gases like nitrogen, hydrogen, noble gases are insoluble in water. They are not soluble. But there are some gases like oxygen, carbon dioxide, okay, they are soluble in water. Oxygen very little soluble, but there is some application. Here also you have to see that how nature works. If oxygen gas is insoluble in water, then aquatic animals and plants cannot survive their lives, okay. And carbon dioxide gas, when dissolves in water, it is forming that carbonic acid, okay, H2CO3. And ammonia gas, HCl gas, they are highly soluble in water, okay. And actually there is some reaction, okay. In case of ammonia, it is reacting with water, forming ammonium hydroxide. Later you can understand. And HCl gas, that is in covalent molecule, okay, that is dissociating into ions. That is why they are highly soluble. Now gases have low densities and has higher kinetic energy than the liquids. So gas molecules are highly energetic, okay, because of this kinetic energy. And if you apply heat, then gases expand very quickly and easily, and that is why sometimes gas cylinders are exploded because of high temperature created by fire. Gas molecules diffuse very easily and quickly from higher concentration to lower concentration, because gas particles are always in random motion. If you spread some perfume, so here is one perfume bottle, okay. So whenever we pressing this button, okay, so perfume is coming, and everywhere we are getting the smell, okay. So that if you just light one incense stick, okay, one corner of the room, and very quickly the gas or the smell that some particles are there, because of this air is present, air is always in random motion, it will diffuse and you will get smell every corner of the room very quickly. So this is the diffusion property. In your book one diffusion activity is there, that we have to take two gas jar. Suppose this is one gas jar A, and inside this gas jar we have taken some reddish brown gas. This is nothing but bromine gas. This is bromine gas. And another cylinder B, inside there is air. Now in this gas cylinder, above these two there is one disc made of glass, okay, and so that these bromine gases, okay, or bromine vapors cannot go out. Next, what we have to do? We have to invert the B jar above the or over the A jar. So next, what we are doing? So we are this is the A jar, and we are inverting that B jar just above it. Okay. Now this disc, okay, we have to remove. Then what will happen? Above there is air. So above there is air, and now we are removing this slit, and now what is happening? This red bromine vapor will slowly diffuse, okay, to the cylinder B, that means the above cylinder, okay. So this is because of the random motion, okay, of the gas particle, okay. So what we are observing here, the color gas diffuses to the aperture, and this is called diffusion. And in case of diffusion, the gases will go from higher concentration to lower concentration, okay. And what it proves? By this experiment we can easily prove that gases have neither fixed shape nor a fixed volume, and practically it has no, that means gases has no free surface. Hope you can understand. Next, we are showing one activity, that if we take some gas, that means air, inside this balloon, then what will happen? The balloon will be inflated, okay, like this. So this also proves that air occupies space. Now if we enter more air inside this, after some time what will happen? The rubber, okay, that outside this this boundary, okay, one rubber layer is there, that cannot bear the pressure and it will burst, okay. In case of cylinder also, if you fill the gas, then the capacity of the cylinder, then what will happen? Huge amount of pressure will burst the cylinder, then there is accident, okay. Now what will happen if we do the same activity, okay, inside a container. Okay. So here container we have taken one balloon. Okay, and here we have already made two holes. Okay. Now first we will block this hole and we will try to inflate the balloon where it is not possible. Why? Inside air is there. Okay, that is creating problem and pushing it so that we cannot inflate the balloon easily. But here two hole is there. If we open this hole, then we can easily inflate the balloon inside this container. Again, when we are just releasing here, it is not closed. Okay, that is why it is coming. Now what we are doing, first we are inflating the balloon. As well as we are blocking these holes. Okay, so already through this hole the air gone outside. Okay, and now the balloon is inflated. Now if we slowly open this hole, what is happening you observe. So the balloon comes back to its original position. Okay. So why this is happening, in next live class you have to explain. Okay. This is one activity. Hope you have enjoyed this class, and today up to this, next day we will discuss about the transformation of state from one state to another state. Mainly two things. Okay, here you have to understand. Already one I have discussed today. By applying heat, we can change the states of matter, and another is pressure. So next day we will discuss in more details. Thank you.